So what's going to happen today is I'm going to start by going over some of the homework in 1.5. Then I will share the review with you, which is now on Blackboard. I'll then give you 20-25 minutes to work on it. I'll probably stop recording because I'll be here for questions, but you'll just be working on it. And then we'll go over the answers, and I'll put those on Blackboard also. And then we'll go on to new material. We'll finish off chapter 1, which is pretty quick, and start quickly at least chapter 2, which is partial derivatives, sort of the first real part of the multivariable stuff. And then tomorrow, as I said, about half hour of new material, so it's all about 2. And then 15 minutes where I'll stay here if you have questions, but then I'll open up the quiz at 2:15. No, you don't have to turn on the quiz review. Right. So in general, for quizzes, anything that we start the day before the quiz will never be on the quiz. Tests are in some ways the same. It's just that the day before a test will be nothing new at all. So it doesn't come up really. Okay. Well, in some ways it'll be through 1.8, but really the only sections that could be on the quiz are sections 1, 3, 1, 4, and 1, 5. There's a little type of question in 1.6, but I won't put that on. So really, sections 1, 3, 1, 4, and 1, 5 is what's on the quiz. All right, so 1.5. Homework. So there's one type of question we didn't really do, so I was in some ways checking to see if you're okay with it. So this is the basic one. It's just here, 2 vectors, give me the cross product. And so the way you get it is by the determinant of this matrix, where you put in the first row the identity axes, I, j, and k, which are 1, 0, 0, 0, 1, 0, and 0, 0, 1. And then for us, it doesn't matter which, but if you want v cross w, then you put in v first, and then w at the bottom row. The reason for us it's not going to matter is we just want a vector that's perpendicular. If you switch the order, all that happens is you get the negative. So for us, that doesn't really matter. And again, the idea is you're working across the first row, so I, and then get rid of everything in that first row in the first column. So you're left with the 2, 3, and 0, 1. And then as you're moving across the row, they alternate. The next one is minus. Get rid of the first row and the second column. And move to the third one. So this is when we get rid of the first row, third column. And I get that. And then remember for this, we're doing forward diagonal minus the backward diagonal. So the 2 minus the 2 times 1 minus the 3 times 0. And the negative 1 minus 5 times 3. And the 0 minus that. And then I usually rewrite it where I get rid of the ij's and k's. So the I is just the first element, so the 2. And negative of negative 16. And again, this has 2 things, one of which we want right now, which you'll see in the next problem, is we're getting a vector that's perpendicular to the two that we start with, which means you can pretty easily check to see if you've done it correctly, because that means the dot product of the vector we just got with either of the two vectors should be 0. So if I take the dot product of this with v, I get -2 plus 32 minus 30, which is 0. And if I take the dot product of this with w, I get 10 plus 0 minus 10, which is also 0, which means I've done it correctly. Either or. So yeah, in general, I don't worry about the notation. So whichever notation you want. Do you mean by, so I guess you could. So if you're talking about doing the linear algebra where you get rid of that first number of the 5, in theory, but I think in this case it's probably more trouble than it's worth. And then the other part that we'll see, forget it, I think the problem after the next one, is that the length of this vector is the area of the parallelogram you get if you draw the two vectors and then the parallel sides. And that we'll use, as I said, in chapter 4 when we're getting surface areas. So we won't use it for a while, but it will come up. So here's the base one. Just here are two vectors, find the cross product. Any questions on steps? Okay, so let's go jump to 28. I should say, again, such as in 1.3, and I forget exactly the problem, something like 17 to 24. There are problems such as what is A cross B if given some information, and what is A dot, and those you don't have to worry about. Which is why I'm skipping those and jumping to 28. So 28 is, yeah, but I think that's one of the ones where I said you don't really have to worry about. So in some ways, those are the more abstract ones. We will specifically be doing it. So the abstract ones you don't have to know. So this one is kind of the other base one, which is give me a second. Wait for a second. Which is here 3 points. They ask you to do two things. First, in some ways, the base thing for cross product, which is here 3 points, give me the equation of the plane. And then later it's going to say, give me the area of the triangle that these 3 points form. So first part. So first we want to find the equation of the plane. And since we're going to be doing this, let me, as I did yesterday, label these points. And that's more obvious, a -2. Here are 3 points. So if I want to get the equation of the plane, what's the first step? Right, get displacement vectors. And it doesn't really matter. So you can go from A to B and then A to C, or you can go from A to C and then B to C, or C to A and then C to B. Any of them are going to give you the same type of thing you need. You might get a slightly different vector depending on which order you do, but it won't change the final answer. So I'm going to use the basic one since it's easy, although in some ways not great for the homework problem, which is we'll get the displacement vector from A to B, which of course is just the vector itself. So I should remind you that you can't just use the points, even though it looks like I kind of am here. And what is the relationship of these two displacement vectors to the plane? Right, so these are parallel. So we have vectors that are parallel to the plane. So we need to get a vector that's perpendicular, and that's what cross product is for. So next step, like the last problem. Oh, so the reason you know it's parallel is we're assuming that A and B, let's start with the vector AB. A and B are both points in the plane. So if I draw a line between the two, it's in the plane. And that kind of by default means it's parallel to the plane. So in some ways, it's the weird way of parallel, which is that we're getting a line that's inside the plane. But since the vector doesn't matter where you are, you can say the vector is parallel. And then the same thing for AC, the same thing for BC, because we're putting together points that are all in the plane. Oops, starting it wrong, sorry about that. So one, get rid of the first row. So the last one. Now that we've done a couple, I'll just get the answers, which is we're going to -1, and although you'll double check my number, -1 minus -5, which is 4. And -2 minus -5, which is 3, so the minus the 3. And then -2 minus -1, which is -1. So that's our normal vector. And again, we can double check to make sure we haven't made a mistake. So if I take the dot product with AC, I get 4 minus 3 minus 1, which is 0. And -8 plus 3 plus 5 is also 0. So it is perpendicular to the two vectors we know that are in the plane. And usually I would just use the first point, but that, again, isn't great for the example. So let me use, for the point, it doesn't matter which one we use. So really I should be using A, but let me use C. And you're going to tell me what is the equation then of the plane? Oh, it's kind of a pain to write it. So. But then we have the negative. Right, so the determinant is +3, but then, yeah. And as I said, I would usually double check, which I just did. I know it must be okay because when I take the dot product, I get 0. So the two parts are the normal gives us the coefficients, and then it's the variable minus the point. And as I said, it doesn't matter which point we use, so really I should have used the first one, because then it would have just been 4x minus 3y minus z is equal to 0. But you'll notice, if I use the 1, 1, 1, distribute, I still get 4x minus 3y minus z, because all the constants are going to cancel. So there's the first part. Second part, which I'm not going to have room to write, so I'll just say it, is they ask you to get the area of the triangle that these 3 points form. That uses the other part, which is we know that the area of the parallelogram is equal to the length of the cross product. So that's the area of the parallelogram. So what is the area of the triangle? Half of that, right? This one doesn't, this part of it, I could ask it at the beginning, but we're not really going to use that. This first part, we will, as I said, start using in chapter 4, where we're getting areas of surfaces and stuff. So second type of question, using facts from the first one with a little extra, and kind of the basic one, which is using it to get the equation of a plane. So any questions on this one? Okay, so one more. Oh, I might not actually do the whole thing. You'll tell me if you want to. Which says, suppose we have a plane that contains this line, and this point, which isn't on the line. Then what's the equation of the plane? And so the idea is similar to the last one. If we really wanted to, we could do it just like the last one, which is we have 2 points, 1, 0, 1, and 3, 2, 1. I could put in a value of t to get a second point that's on the line, and that would give me 3 points. But let's do it a different way. What is the vector that goes with the line? Right, 1, 1, 1. And how can I get another vector that's parallel? Right, I can go from 1, 0, 1 to 3, 2, 1. So I don't want to multiply by a constant, because if I multiply the 1, 1 by a constant, then it'll be parallel, so I won't get anything new. But if I go from 1, 1, 1, 0, 1 to, so if I call this A and this B, I get a vector that's both the line and the plane are in it. That line is, that vector is parallel to it. And so now I'm back to the last problem, somewhat, where I have 2 vectors that are parallel to the plane, and now I would take the cross product to get the normal vector and use one of the 2 points, either A or B, to get the equation of the plane. So they're just writing things a little differently to make it look different. As I said, you could also do this just like the last one, because I could put in t equals 1 to get a third point is 2, 1, 2. So I'd have 1, 0, 1, 2, 1, 2, and 3, 2, 1. And now I'm back to the last problem. Little thing, I said quickly, but if you take the cross product of something with itself, what do I get? Right, I get the however many, actually it's definitely 3. I get the 0 vector. And if there's a multiple, with cross products, you can pull multiples outside. So if it is u times 3u, it'd be 3 times u cross u, which is 0. So if I try doing the cross product of a vector with something that's parallel to it, I get back the 0 vector. And that's because, if you're thinking about it, the length of the cross product is the area of the parallelogram. I have 2 vectors that are parallel. I'm actually not getting a surface. I'm an area, because I'm just getting 2 lines that are the same. So here at this point, here are the 2 vectors that we have. Those are two vectors and we are parallel, so we do the cross product of those two. Two is the displacement vector from A to B, right? So unless you want me to, I wasn't going to do any more because this is just like the last one once we get to here. But any questions about the setup? So kind of the usual things. So those are the ones I wanted to look at. Any other ones from 1.5 that you have questions on? And as I said, ignore the look to see which ones they are. Yeah, ignore any from 17 to 26. So this had nothing to do with the problem. Someone saying one of the ways you can get a second point is by taking a multiple of something, and these are both u's. So if I take the cross product of any vector with itself, I will always get 0, 0, 0. And if it's not obvious, if you just put it into the matrix, it does become obvious. 41. Oh, actually, there's another thing I should have said, which I said this also yesterday. I'll repeat myself a fair amount in this class. Is in the 35 to 38 problem, they're looking at torque, and torque is just the cross product if you have a lever and a force. As I said yesterday, we don't really worry about much of the physics, so I'll tell you what ones you have to. I'll do problems where you need to know it. 41. So 41 is in some ways a similar idea, which is that so I have to spell it out because the next one's going to be similar. The length of the cross product will be the area of the parallelogram, but the two vector. Three-dimensional, so there's no area. Whereas if we take the cross product and then take the dot product with the third vector, we'll get the volume of the parallelepiped that we get. And the reason I didn't mention this yesterday is this we use. So I want to mention it. This is a nice fact, but we don't use it. So the idea would be you have the 4 points, get two vectors that form the base, and then get a third vector that is doing the height. And then if you use this formula, you'll get. And the way you would do it is you would just put in the three vectors and take the determinant and get back a number. So it's an interesting fact, but we don't use it. Any others? Oh, so those are the ones I just mentioned. So 35 and 37, in some ways, is partially where the cross product comes from. So it says, suppose I have they're making it interesting too. Suppose I have a lever that goes from one point to a second point, and a force given by AB0, then what is the torque? And that is the cross product of two vectors. Two steps would be get the displacement vector between the 2 points, and then take the cross product of that with the AB0. So there are two reasons I wouldn't have you worry about this. One is on quiz and test, pretty much always, and I'll tell you when it wouldn't happen, is I'll give you actual numbers. And the second is I will only tell you to worry about physics for certain ones, and this one, torque, you don't really need to know. I don't really know torque very well anyway, so it comes down to 35 and 37 come down to get the displacement vector and then take the cross product of that displacement vector with the vector a, b, 0. Is that okay? You're not going to have to do it. Okay. Anything else? Okay. So what I'm going to do now is, I'll see how well this works. I haven't done this very often. Is I'm going to now you're going to work on the quiz review, which in theory I'm going to share now. So, little question. So, can you see something? No. Okay. Oh, there we go. There. Now you should be able to see it. Yeah. So I had to click on it to see the first one. So this is also in two places. So if you go to course material, it's also under the summer one folder. So now I'm going to stop recording for a bit. I'm going to stay around. So if you have questions, but for the next 20 minutes or so, you're just going to work on these. And in some ways, you're going to let me know. So let me stop recording.